Before we proceed to know in details about the practical 1 and practical 2, let's meet the group members. My name is Muhammad Irfan bin Abdul Rahman.
Hi, my name is Adam Mukris Asfar bin Muazzam Shah.
Hi, my name is Muhammad Adam bin Mustafa.
So for the first practical, basic concepts of statistics and variation. The objectives of this practical are to calculate and describe descriptive statistics, which are mean, variance, and standard deviation. Then understand the concept of correlation and determine the relationship between two variables. The materials needed for this experiment are leaves, ruler, and graph paper. For the methods, 10 leaves have been taken and their length and width have been measured and recorded. The mean, variance, and standard deviation of the length and the width of the leaves have been calculated. Then the data are tabulated in a graph paper. Second step, another 2 sets of leaves are repeated to make 3 sets, which gives a total of 30 leaves from the same tree. Then the results are tabulated as a data matrix. Then the data of all 3 sets of leaves have been used to plot a graph of the leaf length versus leaf width.
Length 15.5. Okay. 13.2.
As we can see, these are the results for practical 1. We have managed to calculate the mean, variance, and standard deviation for 3 sets of leaves. So for the first set, the mean of leaf length is 11.53, the variance is 7.4468, and the standard deviation is 2.7289. And for the mean of leaf width is 4.04, the variance is 0.8093, and the standard deviation is 0.8996. So this is the graph that we have plotted according to the result for set 1 of leaves. For set 2, the mean of leaf length is 11.1, the variance is 3.3933, and the standard deviation is 1.8421. The mean of leaf width is 3.95, the variance is 0.3539, and the standard deviation is 0.5949. This is a graph that we have plotted according to the result for set 2 of leaves. For set 3, the mean of leaf length is 11.05, the variance is 2.1761, and the standard deviation is 1.4752. The mean of leaf width is 4.06, the variance is 0.3093, and the standard deviation is 0.5562. This data has been plotted into graph respectively. Lastly, this is the graph that we have plotted according to the result for set 3 of leaves. Is there a relationship between length and width of leaves? If there is, what sort of relationship is it? Is it linear, straight line, curve, or etc.? Discuss the relationship. Well, yes, there is a relationship between length and width of leaves. The width of the leaves is proportional to the length of the leaves. As we see at the graph for all 3 sets of leaves, the data obtained can be plotted that resulting in a linear graph shape. This means that even we have different set of leaves, the relationship between the length and the width will always proportional to each other. In other words, the increasing in width will also cause an increase in length, also vice versa. Discuss the differences or similarity of the mean of length between different set of leaves. Do the same for the mean of width. After observing and calculating the mean of length between 3 sets of leaves, we found that the mean of length between the sets is quite similar. For set 1, the mean length is 11.53, for set 2, the mean length is 11.1, and for set 3, the mean length is 11.05. These values indicate that the means of length are quite close to each other because the mean between the sets is only in the range of 11 cm to 12 cm. However, this also shows that the average length between the leaves is not accurate even though it comes from the same plant. This trend is also the same for the mean of width between the 3 sets of leaves. For set 1, the mean width is 4.04, for set 2, the mean width is 3.95, and for set 3, the mean width is 4.06. These values indicate that the means of width are close to each other as the mean between the sets is only in the range of 3.95 to 4.1, which is just a small gap between the numbers. However, these numbers show that the average weight of the leaf is not accurate although it comes from the same plant. This shows that even though it is the same plant, the leaf's length and width can vary due to different factors such as environmental factor, age of the leaves, and genetic variation. What is meant by variance? Variance is calculated as the average of the squared differences from the mean of a set of numbers. It is used to measure the variability or spread of the data points. The leaves have different measurements of width and length. What is the meaning of this statement? The statement "the leaves have different measurements of width and length" implies that there is variability or differences in the measurements of width and length among the leaves being observed. In the context of leaves having different measurements of width and length, the variance varies as well. To set an example, for set 1, the variance of leaf length is 7.4468 while the variance of leaf width is 0.8093. The variance of both width and length will quantify how much these measurements deviate from the average data, respectively. In other words, a higher variance suggests greater variability in the measurements of width or length, indicating that some leaves may be significantly different in size compared to others. A lower variance indicates that the measurements are more consistent and closer to each other. Standard deviation is the square root of the variance. It measures the average distance of data points from the mean. A larger standard deviation suggests more variability among the leaves in terms of width or length, while a smaller standard deviation indicates more uniformity.
For the last question, why is it necessary to have different sets of measurement for the measurement of leaves width and length? Having different sets of measurement for leaf width and length is necessary to ensure accurate data, capture variability, and identify any patterns or correlation between these dimensions. By having this, it will help in provide a clearer understanding of the relationship between leaf width and length.
The second practical that we conduct when doing field trip is practical to determine the factor that affect the distribution and abundance of organisms. The objective of this practical are to introduce the simple concept of quadrat, enhance the power of observation, record the difference in plant distribution within the quadrat, and infer the possible factor affecting the distribution and abundance of organisms from natural observation. Material that have been used is raffia rope, measurement tape, stick, scissor, and notebook. Method. First, preparation of quadrat. Quadrat of 5 meter x 5 meter at each for rough type was prepared. Multiple quadrat sample will be performed throughout the habitat at several random locations. Second, observation. All 3 stands that are found inside the quadrat were selected and observed. Third, measuring the diameter. The diameter of breeze head for each 3 stand within the quadrat was measured.
Ada kita ada counter. Depan sini, pokok. Dekat lagi.
As a result, when conduct a quadrat, we have recorded a huge number of species that have been occurred in our quadrat. In our quadrat, we have found pokok kelat, pokok terak, pokok keladang bakar, pokok jering, medang, gapis, keruing gombang, paku pakis, and kelentik kering. You can see it in the picture above. Why is there difference in the number of plant species in the quadrat? Hypothesis or make your own assumption. Discuss the factor that will have caused in this type of distribution. The difference in the number of plant species in the quadrat can be attributed to several ecological and environmental factors. Firstly, it is because of the species diversity and composition. Different quadrats may represent different microhabitats within the same larger ecosystem. Microhabitat can vary in solitude, moisture level, sunlight exposure, and other environmental factors that influence plant species composition. Besides that, at the reference stage, ecological succession may exhibit many species richness. Early successional stage often have fewer species adapted to harsh conditions, while late successional stage may support are more diverse area species. Next, the number of plants may vary because of the biotic and abiotic factor. Biotic factors such as competition, predation, herbivory, and modulistic interaction between plant and other organisms can influence plant community structure. Quadrat with different biotic interaction may support different plant species composition. Abiotic factors such different in temperature, precipitation pattern, and seasonality can affect plant growth and survival. Influence which species can thrive in different quadrat. Lastly, human activities such as agriculture and forestry practice can alter natural habitat, leading to change in plant species diversity and composition in different quadrat. The next part that we have conduct in this practical is we have to answer the post-like question. Define the term quadrat in practice. The term quadrat in practice is an ecological sampling unit consisting of small square area of ground within which all species of interest are noted and the measurements are taken. All individuals on several quadrats of ground size are counted, then the average count are extrapolated to the whole area by using diversity index or relative density formula. Two basic requirements of all quadrat technique. Two basic requirements are area of the quadrat must be known and quadrat must be representative of the area. The advantage and disadvantage of using large or small quadrat to survey the sedentary organism. The advantage of smaller quadrat is easy to handle and to observe and get data and save time, while disadvantage is cannot get huge amount sample we want or rare sample. Problem with spatial scale often make it difficult to directly estimate average density in habitats such as large forest area or in aquatic habitat where one cannot directly see the animal or plant of interest. Explain the issue concern ecologists in conducting the sampling method. Sampling in the huge forest must have a huge cost that we must spend to get data on it, and we have to spend our time, personnel, and equipment during the sampling in the large forest. Issue that has been concerned also in the limitation to detect species, which means that when we do sampling, we cannot think that we will get our target sample because of difficult to detect them individually.
So we have come to the end of the practical presentation. Let's enjoy our montage on some activities that we do at Taman Ula Ulu Bendul.
Find something you can hold on to. Find someone who'll be there for you. Cause that's all that really matters in the end. Find somewhere you can come home to. Find someone that'll die for you. Cause that's all that really matters in the end. It's love, love, love. Cause that's all that really matters in the end. Cause that's all that really matters in the end. It's hard to tell the truth when you lie to yourself. Always give.
So that's the end of our video. We hope that you liked it. Thank you for watching and don't forget to like and share. Bye!